Transformers reread the entire textbook every time they answer a question. A new architecture called Mamba just takes really smart notes, and it's 5 times faster. I analyzed over 50 sources for this video, including original research papers, technical reports, and community discussions. No sponsors, no affiliations, just the research. In the next 7 minutes, I'll break down exactly how Mamba and state space models work. I'll show where they beat Transformers, where they still fall short, and why every major AI company is now betting on hybrid models. Let's start with what makes Transformers so powerful and so expensive. Transformers use something called self-attention, which compares every word in a sequence to every other word. That sounds thorough, but it comes with a brutal trade-off. It scales quadratically. That means if you double the length of your text, the compute cost doesn't just double, it quadruples. Here's an analogy that makes this click. Imagine a dinner party. With 10 guests, there are 45 possible one-on-one conversations to track. Sounds manageable. But with 100 guests, there are nearly 5,000 possible conversations. That's what happens inside a transformer. As your input gets longer, the number of comparisons explodes. This is why long documents are so expensive. It's also why running advanced AI on your phone or laptop has been so difficult for so long. So what's the alternative? Enter state space models, or SSMs. These come from classical control theory, fields that have been modeling signals for decades. Instead of comparing everything, SSMs maintain a compressed hidden state. Think of it like a running summary. This gives them linear scaling instead of quadratic. Double the input, double the cost, not quadruple. Mamba was introduced in December 2023 by Albert Gu and Tri Dao. Its key innovation is selective state spaces. Earlier, SSMs treated all inputs equally. Mamba introduced a mechanism that lets the model decide what to keep. Think about your daily commute. Your brain doesn't remember every car you passed, but it definitely remembers the one that cut you off. Mamba selectively remembers what's important and lets the rest go. Now for the numbers. On an NVIDIA A100 GPU with 80 gigabytes of memory, Mamba at 1.4 billion parameters produced 1,346 tokens per second. Compare that to just 344 for a transformer. That's roughly 5 times faster inference. It matched transformers twice its size in accuracy and can handle sequences over 1 million tokens long. This is not a fringe idea. The original paper has thousands of citations, and the community took notice fast. Now I have to be honest with you. A lot of hype videos skip this part. Mamba is not universally better. If you need to find a specific needle in a haystack, like a phone number in a 50-page document, Transformers win. Mamba's compressed summary can lose those precise details as the document length increases. Transformers also still lead on complex reasoning, in-context learning, and few-shot prompting. A medical imaging study showed Mamba was outperformed by Transformers in chest X-ray classification. The honest answer is that these are different tools for different jobs. Neither is universally superior. So here's what actually tells you where the industry is heading: hybrid architectures. AI21 Labs released Jamba in March 2024, the world's first production-grade hybrid model. It has 52 billion total parameters, but only 12 billion active, fitting on a single 80-gigabyte GPU. NVIDIA's Nemotron-H family replaces 92% of attention layers with Mamba 2 blocks, while keeping a few attention layers specifically for retrieval tasks. The result? Up to 3 times higher throughput than comparable transformers like Llama 3.1. IBM's Bamba 9 billion matched Llama accuracy with 7 times less training data and double the throughput. Mistral AI's Codestral Mamba scored 75% on Human Evil, a major code generation benchmark, versus Code 7 billion at just 61%, and it handles 256,000 token contexts for processing entire codebases. And here's the plot twist. The Mamba 2 paper is literally titled Transformers are SSMs. The researchers proved mathematically that these architectures exist on a spectrum. They're cousins. Mamba 3 pushed the frontier further, solving the parity task at 100% accuracy. So, is the transformer era over? No. But the transformer monopoly absolutely is. The future is hybrid architectures that pick the right tool for each layer of the model. This means faster AI, cheaper services, and advanced AI that can actually run on your phone. The future isn't Mamba versus Transformers. It's Mamba and Transformers working together. If you found this breakdown helpful, hitting subscribe helps us keep making unbiased, research-backed explainers like this one. No sponsors, no hype, just data. Drop a comment below. Do you think hybrid models will dominate, or will pure transformers fight back?